So right now I want to talk about section 10.4, which is the sum and difference formulas. And these are pretty important, so we're going to spend some time here. As such, you're going to have a few problems to do. 1, 5, 7, 9, 23, 27, 29, and 39. So again, I want you to view this as like more than the normal number of exercises because it's more than the normal length of a section. So we're going to have big things we're going to be doing are the sum and difference formulas. Oof. We're going to do the double and half angle identities. And we're going to do the cofunction formulas. So the main thing I want to do is just set up addition and subtraction for cosine and for sine, and then we'll see how to put those together to get the same formula for tangent. So I'm going to give you this little table here. So I've got cosine of u plus or minus v is going to be cosine u cosine v minus plus sine u sine v. Now what this minus plus symbol means is that if I've got a plus here, I've got a minus here. And if I've got a minus here, I need to put a plus here. And it would be clear if I wrote out two formulas, which were, sine of u plus v, cosine of u plus v is cosine u cosine v minus sine u sine v, and separately another formula which was cosine of u minus v equals cosine u cosine v plus sine u sine v. But I think it's good for you to see, because you've seen this symbol before, but now to see it paired with that symbol, I think it's good for you to become aware of this. Okay, next we've got sine of u plus or minus v, and this is going to be sine u cosine v plus or minus, so this one does not flip. You notice this one is the same orientation, plus or minus cosine u sine v. So you see these are very similar, but there are a couple of different things going on. Essentially, the addition and subtraction flip for cosine, they don't flip for sine. Now if we put these two together, that is, if we take sine of u plus or minus v divided by cosine of u plus or minus v, we get, not surprisingly, tangent of u plus or minus v, which is, and actually I'm going to scoot this down because this one's a little bit hairier. If you write these out, you can make some substitutions, and you're going to get tangent u plus or minus tangent v over 1 minus plus, so this one doesn't flip, this one does flip, minus plus tangent u tangent v. All right, I'm not going to prove these formulas, but these are pretty important. And in particular, I've listed them in order. This one is the most important because this is the core of the double and half angle identities that we'll see later. This one is a close second most important just because those two work together. And this one is way down at third most important. The tangent, you can just rederive it from sine and cosine. So that's my ordering. I would like for you to memorize these. Memorize. And this one I would probably give you on an exam. So I'm not swearing that, but I would probably give this to you on an exam. If you need it. So just because you can derive it from the other two, I wouldn't want you to miss a whole bunch of points because you slip a minus sign or something like that. Anyway, let's do an example. Let's compute cosine of 15 degrees. So now the thing about 15 degrees is it's not one of our special values. It's not 0, 30, 45, 60, or 90. So let's use the subtraction formula to come up with a way to write this as a subtraction of two angles we do know. So solution, and notice that cosine of 15 degrees is equal to cosine of, and there's more than one correct answer here, but I'm going to do cosine of 60 degrees minus 45 degrees. And then I'm going to use this formula. So cosine of 60 degrees minus 45 degrees, that's going to be cosine of 60 degrees, cosine of 45 degrees. Now this is a minus here, which means it turns to a plus here, plus sine of 60 degrees, sine of 45 degrees. Then I plug all these in. Cosine of 60 degrees is 1/2. Cosine of 45 degrees is root 2 over 2, plus sine of 60 degrees is root 3 over 2, and sine of 45 degrees is root 2 over 2. And at this point, we spent about a week with those special values, so you should have these pretty well memorized. If not, recall, you can make this chart pretty quickly. We do theta in degrees, theta in radians. We got sine theta, cosine theta, and tangent theta. So the special angles are 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees. In radians, those are 0, pi over 6, pi over 4, pi over 3, and pi over 2. And sine, we've got, well, let's put some lines in here. Sine, we've got 0, 1/2, root 2 over 2, root 3 over 2, 1, 0, 1/2, root 2 over 2, root 3 over 2, 1, and then I've got 0 over 1 is 0, 1 over root 3, 1, root 3, and undefined. So you see, if you don't remember them right away, you should be able to make this chart pretty quickly. And then, of course, 1 over each of these would be, this is 1 over cosecant, this is 1 over secant, and this is 1 over tangent theta, 1 over cotangent theta. So we can make those quickly. And again, recall that sine inverse of theta, which we haven't discussed yet, is not the same thing as 1 over sine theta, which is the same thing as cosecant theta. Okay, so let's do another one of these. Let's do, for example, let's do sine of, let's do sine of pi over 12. Okay, sine of pi over 12, so solution. What are we going to do? Well, we need to find something that has a difference of pi over 12. So I'm going to do, let's do pi over 3 minus pi over 4. Similar idea. So we've got, could I do that? Yeah, I'll do that. So we've got sine of pi over 3 minus pi over 4 is equal to, that's what, I was hesitating, I couldn't figure out why I was hesitating. Yeah, I want to say what the problem statement is. Sine of pi over 12 is equal to sine of pi over 3 minus pi over 4. And if this isn't obvious, that's okay. Let's see what's the math that I did in my head here. I said pi over 3 minus pi over 4. Well, I need to find a common denominator, so that's going to be 4 pi over 3 times 4 is 12, minus 3 pi over 3 times 4 is 12, and this gives me, of course, pi over 12. Right, so that was kind of the math that I did in my head for this step here. Now I'm going to use the sine difference formula. And so how do we use the sine difference formula? I've got sine of u, so sine of pi over 3, then cosine of v, cosine of pi over 4, minus stays minus for sine. Now I've got cosine of u, so cosine of pi over 3, times sine of v, sine of pi over 4, and then I just plug these in. Sine of pi over 3 is root 3 over 2, cosine of pi over 4 is root 2 over 2, minus cosine of pi over 3 is 1/2, and sine of pi over 4 is root 2 over 2. By the way, you can simplify these, but you can feel free to leave it just like this as well. Simplifying, I'm just going to be chasing down some fraction stuff. Useful, but I won't freak out if you don't absolutely simplify every single little thing. Okay. With this, I think that's a